or good evening, whatever time you're watching this educational video about kinematic equations. Before we will begin this video, yeah, by the way, kinematic equations involves displacement, variable, velocity, acceleration, and the time. Okay, I will reveal to you later the four kinematic equations, but you can derive other formulas to make it more than four. Okay, but in this video, I will be introducing four kinematic equations. Okay, so what's the importance of kinematic equations? It aid in understanding physical system. When we say physical system in our subject, it refers to any collection of objects or components that we choose to analyze, such as a car moving or a falling ball. So it's a collection of objects or eh, components that are part of this is a part of the problem that we need to analyze, like when a car moves along the road or in a straight line or a falling ball. So we will consider all the components of the falling ball. It's downward, and yeah, there's a gravity pulling the ball downward. So that's the physical system. Anything involved before we will apply the equation. Okay, anything with mass that can move or interact in a definable way, like what I have said, a falling object. Yeah, we can define that. It must be defined that it has zero velocity, initial velocity, because it starts uh, from your hand. For example, you drop something, when the ball or when the object is in your hand, or yeah, it does not move, so the initial velocity will be zero, and then you drop it, the gravity will pull it downward, and the constant value of our gravity due to acceleration is 9.8 meter per second squared, or in some other reference it's 10. They just round it off. Okay, an example of it there from the slide: tricycle accelerating along the road, a mango falling from a tree, a basketball being shot towards a hoop. So yeah, that's part of the system. That's physical system. All the components involved there. Before we will apply our logic or kinematic equations in order to solve for an unknown variable. That's the physical system that we're talking about. Okay, it describes how do physical system move by assigning measurements in the following variables. We have this: displacement, velocity, acceleration, and time. The three variables, the three variables: displacement, velocity, acceleration. They are vectors. They must have value, magnitude, and direction. The time, yeah, it's a scalar quantity. Fundamental formulae or formulas in solving kinematic related problems. We have four. I just put it four here, but they can derive other formulas out from this fundamental formulas. Okay. The first one, we have D for displacement. To get the displacement, we have two equations that we can use if we will determine the displacement. We have this and this, right? And if we will find the final velocity, we can have this equation and this equation, and also this equation, because we have final velocity here. As long as you have the initial, you have the time, and the displacement given from the problem. If you will determine the initial velocity out from the problem, yeah, this equation can be used because we have initial velocity variable here. As long as you have the final velocity, you have the displacement, and you have the time given from the problem, you can be able to calculate the initial velocity. You can also use this equation to get the initial velocity, as well as this one, as well as the first equation. As long as you have the other variables, okay, you can definitely provide the initial velocity. We have kinematic equations problems. A stone on Earth is dropped into a deep well and is heard to hit the water 2.7 seconds after being dropped. Determine the depth of the well. Okay, so we have 2.7. That's the time. Obviously, that's the time. And then since the ball is dropped, there's an influence of the gravity. And the gravity that we will be um, using, the value is 9.8 meter per second squared. That's the gravity due to acceleration, and we will incorporate negative to denote the direction of the gravity, which is downward. So it's negative 9.8 meter per second squared. And since it dropped into the well, so it started with zero velocity as our initial velocity from a certain point, and then it is being dropped. So no motion, so it's 0 meter per second. That's our initial velocity. Okay, so the given, we have 2.7 seconds, negative 9.8 meter per second squared. It's negative again because, yeah, that's due to gravity to denote the direction of the gravity. And we have initial velocity zero. Zero because it started at some point, no motion of the stone, and then it is dropped. And that's the time that it will record velocities. Okay, and the formula that we will be using is the first equation introduced earlier. Yeah, it's the perfect one because we need to find the depth, depth of the well. So we will have to find the displacement from a certain point where the ball is or the stone is dropped until it reach the depth of the well. And we have initial velocity in our given, we have time. We have acceleration. Acceleration this time is the acceleration due to gravity. Okay. And then we have the time. So it's a perfect equation to use. Let's substitute all the given variables into our equation. So we have 0 as our initial velocity. We have 2.7 as the time, zero point 0.5, and negative 9.8 as our acceleration due to gravity, and 2.7 as the time. And don't forget to to square it. Okay. Now, it's 2 times 7 times 2 times 7. Okay. Sometimes students will forget to do it the right way. It will be canceled out because, yeah, anything did anything multiplied to 0 will result to 0. So you will have this one, and then if you will input all the remaining variables, don't forget to square 2.7 in order for you to get the correct answer. You will have negative 35.721 meters. Meters is our unit since it's displacement. And if you're wondering, there's a negative sign there, it's totally fine because displacement is a vector. It entails a downward direction of the displacement because the stone is falling down. And what if we will provide the final velocity as it hit the ground? Okay, so we will be using three equations that have the variable, the final velocity variable. Let's have this one. Okay, so from the given, we will substitute it here. We have 0 as our initial velocity, and then plus 2, that's the gravity negative, and then we have the negative displacement that we calculated earlier. And then if you will calculate that one using your scientific calculator or whatever device you're using, it will arrive to this magnitude. Okay, and the unit must be meter per second because it talks about uh final velocity. It does not end there because we still have to get the square root of it because our variable is in square root. So we will get the square root of 700.1316, and you will have positive negative 26.5. 0.46 meter per second squared. And we need to get, or we need to take the negative part of it because that's the direction of your velocity going down. Okay. And if ever you want to use the other equation, it's okay. We still arrive into the same answer. Okay, we will arrive to the same answer. So in this case, our initial velocity is 0. We have negative 9.8 acceleration in 2.7 time. When you multiply that one, you will have negative 26.46. Same with our answer. Okay. And if ever you will use the other one, yeah, substitute all the given variables, still you will arrive to the same answer. Okay. Okay, so we have another problem here, but this time I want you to do it, to do the math on your own. The problem you are running upon, you're running upon going to your classroom at a speed of 3 meter per second, and you suddenly see the school principal along the way. You slow down around 25 centimeter and come into a complete stop to greet your principal. Provide your acceleration. So we have we have a term speed there, 3 meter per second. Speed and velocity is related. It's just that the speed is the absolute value of your velocity. Okay. So speed and velocity here. Yeah, same value. We have your velocity here. Um, and then you will have 25 centimeter. You slow down until you stop, right? And uh, the moment you slow down until you fully stop, it the measurement or displacement is 25 centimeter. You need to convert this into meter for you to have uh for you to have the the correct units in our answer. Okay, and then you need to find acceleration meter in meter per second squared. That's why centimeter must be converted into meter. Okay, so you can pause this video and then you do the math and make sure that you will arrive with this answer. The answer must be negative 18 meter per second squared. Thank you, and I hope you enjoy our lesson. I mean, the video today, um, or whatever time you're watching. Yeah, you can also subscribe to this channel for more physics related videos. Thank you so much.